So, hello, nice to see you here. Welcome to my talk, Another Year, Another Language. So, the point of this talk is that I am active on some message board, which is, this is like Polish community for software developers. And yeah, this is a community, so people ask their questions and we answer them. But it's not only about technical stuff, it's also about just life and things like that, and trolling and everything you have in internet. And like twice a month happens something we call the drama post. And typically this is in Polish, but the translation is like that. I will just translate you what happens. Like someone is like, oh, we always have new technologies. This IT is just no life. Like, why always new frameworks? Why these new programming languages? Who even creates those stupid, crazy languages? Yeah? And those are valid questions. Like, so that's IT life. And for me, it was always normal. But being like exposed to so many questions like that, maybe there is a problem. Maybe we are doing something wrong. Why it's like that? So my questions to you is: do you remember your first programming language? Yeah, okay. Well, shout it! Help me. Shout your first programming language right now. Yeah, okay. I knew BASIC, like mine. That's the best one, of course, ever. And okay, so we learned some language, but the question is it still your favorite language? Okay, but you have some favorite language, right? Some language you would all write everything with this language. You know it, you like it, or you maybe don't know it, but you want to know it. And you will do everything in this language. You have it? Do you have this favorite language? Shout it, please. Now. Oh, Java, I heard. No. I thought, I know the truth. Come on, I made an analysis, really. This Java is just, that's only for the HR, that we are only doing PHP mostly. But okay, there is a page that I love. There is like one simple algorithm, and algorithm is even said too much. Very simple loop that you have to implement in any language you know. On this page you can post it, and so far it's posted 1,500 solutions in different languages, and even like 5 of them in Java in a different styles, flavors of Java. And I like to look through these languages and just to see how sometimes crazy they are. So, for instance, there are solutions written in macros or configuration languages for something, which accidentally appears to be Turing complete. But anyhow, the question is, how could it happen? Yeah, that we have 1,500 languages that are, and that's not all the languages that are right now used. Those are only the most popular. Oh, okay. The popular, there are more than 2 software developers. Okay, so let's see how it happened. First, we need to see how the hardware happened. So, first computers. Do you know the first computer? What was the idea, how the idea of computer was born? Okay, the picture that should help. You know this? Yeah, Babbage, analytical engine. Actually, so this thing never worked in 19th century. Recently, they tried to make it working. I haven't checked if it's already working, maybe. Because basically, that was the idea of computer. And at the beginning, it meant to be simply better calculator. And it was totally mechanical with possibly a steam engine powering it up. So if you are somehow in a steampunk, you would love it, really. I recommend. There are books about this. So this is really interesting story. But yeah, at that time it was too expensive to really build something working. So it has never been finished, but actually the guy, the Charles Babbage, really had a clue how computers should work. And this is more or less the first computer program documented ever. It doesn't look like a computer program now, but do you know who was involved in that? Ada, of course, Ada Lovelace, this nice lady. So she's like a icon of being a software developer, the first that we recognize. Okay, and So we have this steampunk story from 19th century, but as you see in this programming, it was just a sheet of paper, and it was more description of an algorithm than a real language. We needed something that would be a language. And do you know this? Of course, it's Lambda calculus. And the thing is that it was invented by Alonzo Church, described in 30s, so long time ago. And it wasn't really meant to be a computer programming language. That was the language for mathematicians to describe algorithms. And so basically, if you do any mathematical procedure, how to describe it in something more formal than just English or whatever language you know. And he created this formalism, we call it formalism, and it's really beautiful, it's minimal, and basically all in the all the concepts you have in from mathematics, you can express in Lambda calculus. You can express natural number, integers, real numbers. You can express what, for instance, a list is. You can express in Lambda calculus what is a sorting, and you can implement. So this is a formalism that allows you to describe not only numbers, the objects in mathematics, but as well the algorithms. So if you haven't heard about Lambda calculus, this is really, I would say, one of the most interesting areas you can dig in, because it's really beautiful. And however, it is like, I call it low-level language of mathematics, like machine language for mathematicians. And but it's actually a Turing-complete thing. And it could be considered a programming language, although very hard to write in. And I even call it that it's so good that you don't need a real machine to work with that. It just runs without computer. It's beautiful. The thing is that in one moment in history, we had this. We had machinery, and we had like kind of a spirit we can put the languages. So that was a time when we can really talk about computers in the 30s. And do you know the first computer that really worked? Okay, nice try. No, that wasn't Commodore. Okay, now I only bring it to you because this story is known, but it's more complex than what people typically see. So the computers, this is one that it's actually the guys got a patent for that. That is the first computer. Have you ever heard about it? Mostly no, because those guys didn't even know they created something that interesting, and they helped in building ENIAC, and after that they realized, oh, that's something everybody now talks about, but we built it like 6 years later, 6 years before, and we didn't know this is something interesting. If you ask this question about first computer in any German-speaking country, you would hear about this. Have you heard about it? No, but because, of course, Berlin, year 1941, after the war, it wasn't really politically correct to say that the guys invented something really that was a breakthrough, and especially Konrad Zuse. So this is electromechanical computer. So basically, it uses electricity and mechanical parts, very noisy, and you can read about this story. So Konrad Zuse actually also created something that could be first high-level programming language, but we'll not talk about it because, again, I think for political reasons, it didn't play any important role in history. It was just forgotten for years. And then came all the stories that you probably know about Colossus, ENIAC, EDVAC, BINAC, whatever. Commodore a bit later. Okay, so, and that's how programming looked like. So, before we had these papers by Ada Lovelace, and now we had some switches. By the way, do you see that still we see women on this picture? So Ada and now women. If you look at the pictures from that time, you see that mostly software developer was something that women would do. They changed something, but okay, I don't know why. But yeah. But that was those times, and you see that they switched some switches. So programming wasn't very handy. They didn't have files, but already they did something else as just writing this on the paper. And if we look how this programming looked like, we can represent it with something modern. And now I think at least somebody from the audience can help me that. This is how programming looked like at that time? You would talk about this as a program. What is this? What language is that? It's machine code, of course. And do you know what it does? Okay, this is not from 40s, it's from 70s, from 80s. And this is for a processor called 6510. So at least some of you should read it fluently, no? If I tell you that you have to put it in this address in memory, F0 is a conditional branch, so we jump F0 and then 8 bytes, like, oh, it does 8 bytes. You know what it does? Okay, you don't know, but at that time everybody would know that. Of course, this is a machine code. And it's actually, this is a nice language, which is actually very simple to learn. Really, the rules are simple. The problems is calculating these conditional branches. The problem is remembering all these opcodes, because each number means something. And at that time I was programming Commodore 64. I had like 150 opcodes to remember. That was really possible in one evening to learn all of them, of course. But now we have like 4,000 on the modern processors, a little bit more. And this is basically very mechanical job. So you know what to do, but you have to calculate or remember everything. So rules are simple, programming is hard. So people needed something better for that, and they created another programming language, and now it's completely readable. You know what is this? What is this? Assembly code. Basically, it's actually doing the same thing as that before. But now you, of course, know what it does. Oh, come on, everybody reads assembly. This is a very simple language. Okay, so it was like created in 1949. Yeah, for those people that cannot seem to remember stuff, yeah. And assembly is like, why it was popular. At that time, the machines were simple. They had really bytes of memory. They were slow, noisy, and you needed something that translated directly to machine code, where a compiler, assembler, was simple. And they created this assembly language, which, by the way, is kind of portable. So in history, there are moments where bigger programs in assembly were ported to another architectures, and they worked with search and replace. Even now it happens. It's not just popular that we write assembly right now, but at that time it was happening. But of course it still inherits a lot of a problem from machine language, like registers. You have all these registers in CPU and have to remember, oh, I put this in C register, but what was in D? I don't remember. You have to check. You needed comments. And yeah, that's how programming looked like. So people needed something better. But the hardware was, before doing something better, they had to be done changes in the hardware. And for instance, this thing appeared. Do you know what is this? This is a memory. In a mercury, so basically it's a memory where state of cells are waves in mercury, really in liquid. And basically, if you are angry, you don't stop on the floor, you don't shout, because it will erase or change what's stored in the machine. You had to be really patient while programming the machines with that. But it allowed machines to process the bigger programs. So assembly was not efficient anymore, because if you wanted to write something bigger and you wanted not to waste time on remembering all this register and stuff like that, so people created this. You know the language? So actually it's not basic. It looks like, but it's not basic, because if you look at these numbers, there is now 1,000 and now it's 3,000. So it's not basic. Yeah, thank you. It's not visual basic, it's a FORTRAN. And simply about FORTRAN, designed in 1957, and it was just very close to assembly, compiled to the fast machine code, but you didn't have to care about registers. Things like jumping in assembly were replaced with goto, of course, as a hell. It had a very funny type system. I love it. You had the variables with different names. If names started with I, like I1 or N or whatever, that was an index. It meant it must be integer. Otherwise, it was just kind of a float. So you don't have that goodies in the now modern languages. By the name of a variable, you know what type is this. Yeah? Okay, so, but it was designed for mathematicians writing down the algorithm in the software. And it worked well because mathematicians use indexes with I, N, whatever. If they write A, it means it's a number, not an index. If they write I, mostly it's an index. So it's very handy for mathematicians, and that's why we have still a lot of algorithms, mathematical algorithms written in FORTRAN. But mathematicians had their language. But business didn't have a language, and people who are not scientists. And this lady helped them. You know who is she? Grace? Yeah, Grace Hopper. And she invented one language which is kind of forgotten right now, but she then took part in the development on other language which is very successful even now. And you know what's this? Come on. COBOL, of course it's COBOL. The beautiful language, you see, for instance, move first number to display number, display something, move second to display. You read it as English. It's very readable. You don't need the comments anymore in COBOL. So this was like first clean code programming. Yeah. So again, the COBOL was still very simple. So it guaranteed the fast compilation and efficient code produced because it was still close to assembly. And yeah, that's it. Although it brought extreme ceremony. If you think that Java is bloated, you write a load of code or boilerplates in Java, try COBOL for one day. You will think that Java is like, you know, as Ruby compared to what COBOL is to Java. You know, it's like really, it's so efficient. Just 2 characters and everything you have done in Java. Because there is some measurements that you need like more than 10 times lines of code in COBOL to do the same in Java. I think it's even greater number. I just forgotten the real number that was measured. But okay, we see the reason why those languages were created. Assembly, COBOL, because we could automate some stuff that is boring for developers, but doesn't really change the way you want to do. It's just automate, you know, calculating of branches, remembering registers and stuff like that, jumping, whatever. So we can code faster. But the hardware was changing. And for instance, we had this. So FORTRAN was, for instance, written on the punch cards. And it was possible with a punch card to write bigger stuff, so longer programs. And those are, you know what is this on top of that? Vacuum tubes. So before, computers were electromechanical. So they were real switches and they were really noisy. So after that, they were fully like electronical and they were a little bit faster, although still big. And what was possible with that was another language that would use that. More memory, faster computers, and we can now write more stuff. And this happened. You know what's this? Yeah, scheme Lisp. That's Lisp, basically. The first Lisp, okay, it's not really looking totally as the first Lisp as far as I remember, but this is the idea. The language appeared, and basically that was a concept. Don't think from hardware perspective. Don't make it easy for the hardware. Make it easy for software programmers. Think about language for them and then worry about compiling it. That's how Lisp was created. So this is a beautiful concept, completely new paradigm. By the way, functional programming, and it was elegant, the first language that you would call elegant. But the problem is it was largely forgotten for years or ignored because it wasn't that fast and people really cared about cycles still in 550s. And the other problem, it was hard for the people thinking in a, let's say, assembly language, thinking about go-tos, etc. That was completely, let's say, different stuff. Yeah, so because of that, actually Lisp was more ignored and something else happened. Another language appeared, the language of computer scientists, because now we had the computer sciences. Before we had the language for mathematicians, after that we had the language for business, and that was the language to write down algorithms. So you know the name probably. Algol. And if you read any book about, older book, about algorithms, typically they present algorithms in Algol, because that was language exactly done for that. It's not as extreme as Lisp. It's closer to FORTRAN. Actually, it was at the beginning better FORTRAN, but it's this language that's, by the way, it's language that you write pseudocode and it's almost the code, like Python nowadays. So, yeah, but we will not go into details of Algol. The interesting thing is that this language was really taking over the world, and in one moment, great computer scientists gathered and basically decided to write a new specification of Algol, Algol 68, that would be awesome. So they gathered, and every one of them brought something into this language, one piece. Those pieces didn't work well together because this was a language that supports all possible ideas. Brilliant, each of them brilliant, but all of them. So it is classical. If you look for what means designed by community, you find out Algol 68 as example. And it was so hard that it was impossible to write compiler for a couple of years. And it has so many operators, it used so many operators that even now it would be hard to write down the program. With Unicode it's possible, but at that time that was a typical writer for a software developer. So there was like huge gap between the reality and what was in the language, and basically this was like one of the greatest disappointments at that time. The language that had to be like the breakthrough in industry was a big disaster. But the hardware was changing, and this appeared. You know what's that? Why I love it? It's something called, oh, sorry for the quality of the picture, I didn't upload the correct one. This is like core memory. Okay, I wanted to make it hard for you. Core memory, it's like one last memory produced by industry where you see each bit with your eye. You don't need magnifying glass, really. But it was so much better and dense than the vacuum tubes that it basically meant a technical breakthrough, and we could store more things. And we also had this. You know what's this? You should know this. This is a very famous picture. First transistor that actually meant to be smaller than a vacuum tube. If you look at it, it's actually bigger than vacuum tubes, you know, but this is just a let's say, first prototype working. But this allowed us to create even more crazy languages. And people took this opportunity. For instance, this language I present you is very important because it brought this concept. Null reference. So the language, okay, language is called Algol W. And by the way, this was just alternative Algol for those that were disappointed with Algol 68, and was created by Nicholas Wirth and Tony Hoare. And basically that's the point. Null was brought into the business, and Tony then later said it was his billion-dollar mistake, and he confessed that the null was not there because it allowed something. It was just easy to introduce it to the language, so he took a chance that he regrets now. Okay, so that was one of the things. Then we had another language, this one. This is, I put it here because of one thing. It used this. What is the language? Okay, this is like, we can call it like grandfather of Java, because this is BCPL. So something that was before C, and it was a language for operating system programming. And it had, for instance, only one type. So it was the very mechanical, sympathetic language that basically it used only the word that was fitting exactly to the machine architecture, only this type. And because of that, for instance, it needed Hungarian notation. Thank you, BCPL, for bringing this horrible concept to us. Yeah, because if you have only type, you have to put what you actually have into the variable name. That's why it happened, Hungarian notation. Okay, but this was one thing, and then we had this language that I love. And you know what's this, of course. Everybody knows this. Basic. Why it's important? because it was the language that made it basically brought programming for the masses. Now everybody could program. Okay, computers were not that popular at that time, but if you had one, we were lucky, and you had one of those first available for everybody computer, you would use BASIC, because it was very easy to get into, because it had interpreter. You no longer had to compile and just fight with the errors, syntax error. You had an interpreter that was instantly telling you what you are doing wrong, and you could basically interact with a programming language. It's just like REPL right now. So it's really cool. But of course, it had go to everywhere, variables that were uninitialized, and all that stuff. So, but it was really a breakthrough. And by the time BASIC was becoming more and more popular, we had these things in hardware. Basically, this is memory, but really as a chip right now. And this is a very important thing. You know what's this? I think this is the second CPU produced by Intel. First one was for calculators. This was for computers, and it was a great disaster. It was slower than the same thing built with transistors, not as a chip. But the company wanted to do something with that, so they created the successor of that, this processor. And basically, this is how Intel branch or family of processors started. The processors that you have in your machines. Because of that, it's such a disaster. Because it started so long time ago with the first chip being broken. And they tried to fix it for years, never succeeded. But okay. So this is a machine with this chip, and I put it only because those guys coded for this machine. Yeah, you know who is this? Our heroes. So it's Gates, Paul Allen, and they really did it. They programmed BASIC for Altair, not even having access to the computer. They did it on a tape without having access to the real computer, only having partially broken specification. That is so awesome. And it worked for the first time, written in assembly. By the way, this assembly was later ported to different architecture, exactly assembly code. But okay, this was era of BASIC, and that's how Microsoft started with Bill Gates coding in assembly. They made it popular, and yeah, everybody was doing BASIC. But then this guy he stepped into the party and broken it. You know why? He said that. Of course, he said that before, but it was popularized later. Yeah, Goto isn't that good. When I first time heard it, I was like, what? That's the basic thing you do in a programming. You can't program without Goto. And that's basically what other people said. But Dijkstra convinced that if you do Goto, you just create spaghetti code. You should do it differently with different constructs, like for instance, with a different language than BASIC. BASIC is simply broken. And for instance, the answer to Dijkstra problem were different languages, like for instance this. This you should know mostly. Pascal, the language that brought something called structural programming. So you don't see Goto, you see functions, you see if statements, okay, but without Gotos. And there were while, repeat, and etc. constructs. So Pascal and structural programming was created so that we don't use Goto, so that we don't have errors. So basically structural programming, if you do that, you don't create spaghetti code, of course. Yeah, but the thing is, and that is the reason I see why we have new languages. I will get into that later more. We create more sophisticated language that prevent us from making stupid bugs, that make those bugs impossible. Okay, so then we have next step. Before we go that, one thing. Some people didn't agree with Pascal and structural programming. They said, yeah, Goto is broken, but there is better alternative. If Goto is broken, we introduce come from. I love this idea. This language exists. You can program in that. By the way, they brought instantly more concept. Like for instance, you should be polite to your compiler, like writing please statements. but not too polite. By the way, this compiler has a rule. If you write please too many times, you get an error because you are like, you know, I even forgot the name, but you are too polite. You are obviously lying. So this is really cool language to program. It's called intercol, and it's considered to be even the first esoteric programming language, so made for fun. Right now we have more esoteric languages than the real ones. And some of them are just made for fun. Some of them are made to prove some concept that something is possible with programming. So I do love them, actually. I don't really like brainfuck because it doesn't really bring anything sensible. It's just another assembly. But there are more languages, like for instance, Lambda, that are really completely new concept of programming that I really like to read about and even try sometimes. But okay. But slowly the hardware was changing, and we had disks, hard disks. When we had hard disk, we could have more sophisticated programs that were composed of many modules that were so much bigger than the things we were writing in Pascal or whatever before, and we needed programming language that could use that, and that would work with that. You know what is this, of course? C language, yes, and it's beautiful. You see, so it inherited syntax from BCPL, these braces, and yeah, it was very popular. And by the way, it is now considered to be OS programming language. But there is one thing. People sometimes say, if you do OS programming, you should use C because it's exactly for that. There's nothing in C that supports OS programming, really. If you look, there is nothing like changing the security ring from 0 to 3. There is nothing that supports hardware interrupts and nothing like that. All of that supports OS programming is done in a compilers, in some pragmas, in linkers. The C language actually is just normal multi-purpose language. So you could do that support for OS programming into any language, even to Java. People just don't do that because, especially in case of Java, that would be even stupid or very hard. But nevertheless, this language became very, very popular. And yeah, especially because it was still quite low level, although already enabled people to do bigger projects. But of course, it had the problems, like especially mallocs. Who remembers mallocs? Nightmare of managing memory, yeah, with your hands. Oh, that's disgusting. And by the way, people said it doesn't have encapsulation. Actually, C on the level of units has encapsulation, but it is not very friendly to the people. So people wanted the new concept. C was like a ultimate structural programming language. People wanted something more, and they created this beautiful language. You know what's this? This is a functional programming language. For instance, sorting is done with functions. You see, sort from here to here. This is beautiful syntax. It's functional programming brought to the world. So this is, yeah, C++. Although it wasn't known for being functional programming language, it was known to be object-oriented programming, yeah, and brought that. It has better, easier to use encapsulation, modularization than C, but still it inherits the problem. Like, you don't have malloc, you have new. Oh, so big change. Thank you. And if you ever took part in a bigger C++ project, you know what can happen if someone overloads, like calling a function operator or a star operator. That's really funny thing happen. So this was interesting. Okay, and it didn't, for instance, have a security. What I mean, if you are in a bank and you wanted to use some library, third-party library, you could do that. There was no Maven. Even now in C++, there's nothing like Maven to download easily my library. You just go to some page, you download binary and headers, and you use that. And then you wonder, what if this manipulates memory somehow? Because it's easy in C++. What can I do? Oh, nothing. That's how it is. So it wasn't really well fitted for internet, but exactly at that time, when C++ was very popular, we got networks, internet, and it needed a new language. And this appeared. You know this beautiful language? How beautiful is that? I have a list of objects, of strings. I have to enumerate it. I ask if it has, create enumeration, ask for more elements, check if it has. Then I take next element, of course, as an object. At that time, Java had no generics. Then I check if it's really a string, because who knows what else can there be. Then I cast, oh, there is an error. The thing is gone, but I cast it to the string and then I print it. Oh my God. And you see how I felt when I switched from C++ to Java. That wasn't real. So if you switch to Java 1.2 for one day, you will see how I felt at that time. But okay, it breaks with a C compatibility. Basically, it's not like C++, although it has similar syntax. It's more portable thanks to JVM, easier to port, better defined. It had a great standard library, something we now forget about it, but Java was one of the first major languages that had all like network programming, network support in the standard library, threads, etc., security, and desktop programs, etc. But one thing, Java wasn't brilliant at the beginning. Try this, Java 1.2, Java 1.1 for one day, and you will see that. But it became very popular. Why? Because it was for free. Really. I've chosen Java because I started to develop commercial programs at the end of my university, and then didn't have money to buy the good C++ compiler. They were too expensive. I had to write in Java. Okay, thanks, Java. Okay. And now we go to the most successful language. We will see it, and instantly you should know it. Recognized by the syntax. What is this? Of course, you see it's JavaScript. Yes, it is a valid JavaScript. You have never seen JavaScript like that. You can write any JavaScript program only with these characters. Any. There is even a special page where you put your own JavaScript and it converts it to this form. It's called JSFAQ, but it works. This is the inverter of JavaScript. I basically, put this sensor because I don't think he's very proud of the language. In fact, in the core, JavaScript is a very beautiful language. It's kind of a Lisp brought to reality, and that's what the author wanted to have. But he was convinced, as he says, by business, that he should do something more similar to Java and C. He wasn't happy with that, but he did it. So he created a monster. And yeah, I don't really say that JavaScript is totally bad, but it's surely a wasted chance because it's really beautiful in the core, but some people around it are really ugly. And okay, I don't go into the details, but we see other reasons why we have languages. JavaScript was for all these browsers. Java was for, of course, the refrigerators. I don't know, I don't have Java in my fridge. Maybe I have, I don't know. It's hard to check. But we have some special purpose languages like those that sometimes because generic purpose. If at the beginning of JavaScript, someone would say that we will program servers with that, ooh, that must have sounded strange. Even today, for some people, it's strange, but okay, we do that. Okay, now we're going to conclude slowly this talk because I'm out of time. Oh, still 10 minutes, but we've seen different types of language. So what kind of languages you will see? For instance, you can categorize languages into the scripting and compiled ones. And both of them have their advantages. Scripting languages, you do something really fast, you don't care about the future, so you choose JavaScript because you are at the party, you want to calculate, you want to amaze your colleagues. It's so much easier to do that with JavaScript than with Java or anything else. Or you are really doing a bigger project and you see, oh, we are in corporation, it can be done in a week, but we have to do that in 3 months anyhow. So we choose Java, create 3 layers, 5 layers, we are professionals. And we do that with compilers that would help us. Okay, that's how we do that. Come on, I know the truth. But of course, compiling means somebody checks our program and checks for errors. If there are like more than 1,000 of lines of code, you really see that compiler brings some benefits. And you have this is associated. Typically, scripting languages don't care about types. You just put something, and you know this was a string. So in the next 3 lines, you know this was a string. Statically typed language store this information, and compilers check that. So if you put a string and you want to get integer, you get an error, which typically helps you. Okay? And we have this. By the way, this is a lot of confusion. We have dynamically typed, statically typed, strongly typed, and weakly typed. So just as an example, C is a statically typed language which is considered to be weakly typed. Means in a C, in a compilation time, you have integer or byte, but you can cast it to whatever you want. You can cast integer to byte of characters, and nothing will prevent you from doing that. And in the runtime, C doesn't know what type you have. This is contrary to Java. You can even cast something to object, integer, and then cast it back to string. It will compile, but in the runtime, you will get a failure because Java knows the types, and it's strongly typed. So sometimes this, let's say, categorization is not that strict. So for instance, if the language is strongly or weakly, there are some more levels of gray, of shades on that. But okay. Nevertheless, having a type system means you have to write down types and compilation. Some people use scripting languages and dynamically typed, and then they complain that I have to write a lot of stupid tests that if I pass a string, I will get an error, or I have to pass string. How to help myself not writing those many stupid tests? And that's the best answer I've seen from Mario Fusco. That's exactly, if you want to avoid lots of stupid tests, you use statically typed language. That's exactly the rule, by the way. If you think of having constant quality of your system, if you are doing something with statically typed languages, you don't have to write so many stupid tests. If you do the same with dynamically typed languages, in order to keep the quality, you have to write a lot of stupid tests, and you have to judge. Typically, okay, that's up to you. But even, I don't say, for instance, Java is slightly toward right part of this axis, and there are languages that are more strictly typed, more typed. And you have to write, you don't have to write as many types, as many tests as in Java. So just for you, yeah? So it's always a choice. So by the way, is there anything better than writing always these types and then checking the compile? Actually, this language, you should recognize it. What is this? This is Scala. I made it especially confusing because it would also compile, I think, as a JavaScript and as a TypeScript. But the thing is, you have this vars or vars, whatever. You don't care about types in Scala, but they are there. Compiler, from the context, guesses. Actually, that's not guessing. There are hard rules, and this is a type inference that we even have in Java, but very limited. Now it's better with var, but what is in Scala is way, way more than what's in Java. So we have both of the best two worlds. So Scala is, of course, functional programming and object programming hybrid, but type inference means you have a type system. This is very strict, but you don't have to write that much. This is cool. Okay, I don't have time to write much about Java, but Scala to talk. One thing, it compiles, what I've shown was Scala.js. This is normal Scala that you can compile to JavaScript. Not many people know about it. For instance, I am programming web pages like that often, really. It works on production. So, and this is the point. You have strongly and statically typed language, but without much of ceremony. But the problem is with Scala, people consider it sometimes to be too complex. But it doesn't have, you don't have to write down semicolons. Come on, you should love that. That's the best thing you have in Scala. Okay, but while we now talk about Scala, it was a while ago, but the things are still changing. Hardware is changing. What we had in the last few years was this, multi-core processors. We have many cores. And right now, we see the era of the new languages. Actually, the languages that were created a long time ago, but never became popular until recently. You know this? This is, of course, Haskell. It was designed in 1990. This is functional and almost pure functional language. You can break this purity, but it is quite pure. And the thing in Haskell is, because you don't mutate, it's so much easier to use it in multi-threaded systems because you don't mutate shared state, which is typically a disaster that you have in Java, even Scala, whatever. With functional programming, you can really, it's easier. You can really protect yourselves from those bugs. So this is the reason why Haskell recently became more and more popular. For instance, I'm a little bit involved in popularizing Haskell on JVM called ITA. So we can even take any Haskell program and connect it with your Java and even run it on WebSphere if you like, if you are so crazy. Okay. But now we go back to the JVM. With Haskell on JVM now works. Java, that we love, has some problems. People know it has a ceremony. Functional programming with Java 8, come on. If you are into functional programming, you will see it's not really that. It's very limited. So some people need more. And type system in Java, it's always with each version, it's better with each version, but it's still very limited. Generics are not that cool. In fact, okay, today I was on the talk in this, I've forgotten, and I've seen that with Java 11 came some new features that I actually can use, but okay, we'll see. But the problem is, language was designed as really better C++, okay, better, safe C++, long time ago, and now we bring and we try to fix it because generics something to fix the original concept. And it happens the same as with your every beautiful system that you design. You have a really great concept at the beginning, you do it, and after 2 months comes business and they say, oh, we have to change some things, and now you have to adapt it. And your beautiful code, your beautiful architecture collapses in this moment. Now, and they say you only have 2 weeks. Okay, in case of Java, it was years, but basically Java is now partially broken. Okay, I mean broken. It works, it's still consistent, that the code is consistent, but it's not beautiful anymore. Java 1.2 was very primitive, but it was very consistent language. It was like everything could have been done in only one sensible way. It was to some extent beautiful. Recently, you have a lot of choices. You have vars that you can only use inside of the method body. You can't use var as a field or whatever, which for instance in Scala you can, in Kotlin you can. So Java is now even more complex in a syntax to some other languages like for instance Kotlin, because even though it's less, let's say, it has less feature. But the thing is that we have a lot of things to choose, like Groovy. It's kind of like, almost like scripting language. Like you do things fast, you don't care. And it's more functional than Java. You have Clojure, which is basically Lisp for JVM, which is functional programming, the real one. You have Scala that supports everything. I love it. Language that everything, every concept you can imagine is in Scala already implemented. Or Kotlin, which I call Scala --, Java++. By the way, last year I'm mostly writing Kotlin code, and I'm quite satisfied. It's now hard to me to write Java again. Or ITA, which is basically Haskell. And you have a lot of other choices. These are that I tried. Okay, so what do you think about learning another language? Because I've shown you history, but now let's conclude. Like, language is first a syntax and semantics. Well, you write something, what does it mean? But also library, what we have in standard. Java is particularly rich in that. So all the JVM languages benefit from that. We can use everything what's in the standard Java libraries in the modules. And a lot of tools. That is where Java is totally brilliant. Even now, the tools for Scala are not as good, for instance, as for Java. They are better each year, but it's still a gap. Okay? And one thing that people forget sometimes, community. There are languages that when you put a question, you will get nice answer relatively quickly. There are languages where you put a question that I don't know what to do with this code, you will be instantly punished that you should read the books or whatever. There are differences. You should be aware of that. For instance, people say that Python community is extremely helpful. I've seen that to some extent. Okay, but the thing is that we see some reasons for the languages. Productivity, make things faster. Hardware, we have a better hardware, let's use it. We have a new hardware, let's use it. Or we have ideas. I have a crazy idea like Lisp. Check it if it works. Or like intercall. Or we have one last thing. We want to not repeat the bugs that we were doing in the past. For instance, this one. If we have problems remembering opcodes, we create assembly language. If we don't like go to spaghetti, we go to C or Pascal. Which we see the problems in C that with encapsulation, we go to object-oriented C++. And if we are fighting with dangling pointers and things like that, the garbage collector in Java or C# fixes for that. And if we are fed up, we don't like null pointer exceptions anywhere, we can fix that with Kotlin. It solves the null pointer exception really well. Okay, not totally, but quite pragmatic. Or if we see the problems with mutability, we go to Haskell or Scala. Or there is even, for instance, concurrency problem. But it means you should expose more information from your compiler. Like for instance, malloc was just a function call in C. In Java, you have new A, and compiler knows you are allocating the object, so I can trace it later. Or for instance, semaphore lock, just a method call in C++. But in Java, you have keyword. You expose more information so that compiler prevents you. Same in Rust with multi-threading, etc. Or other languages, other productivity. You just do the stuff, you don't care. Like simple maths, you go for FORTRAN, either algorithm for Algol. I just care about processing data, I go for Python, etc., etc. Or I have a new hardware possibilities, like memory was limited, I could only use ASML, COBOL, or FORTRAN, but I have more memory, I have Pascal or C, even more memory, I can use it with Java, huge objects, or I need to work in a network. It's safer to do and really productive to do that with Scala and Haskell. And this is like a loop that I wanted to present you. We have a new hardware. When we have new hardware, we can try new ideas. But if we try new ideas, we bring new bugs. We want to fix those bugs, so we bring restrictions to the languages. And restrictions means more ceremony. Then we are tired with the ceremony, so we go for productivity with less ceremony. And we solve the problem for a moment, but in the meantime comes new hardware and spoils all this concept. And we are in this endless loop, and I see that. So it means you will see the new languages. And they are not there to destroy your life. They change the way you think. For instance, this is program in Java, 2 methods that are very similar. I even written to do that I should really unify them into one method. Never could do that until the moment I've written program into Haskell, and instantly I've seen how to make it one method. This way of combining this would work also in Java. It works in Java, but I only seen it once I've written program to Haskell. Wow. This is the point of why should you sometimes learn. And if you say, my company will never do Haskell, Scala, whatever, in a companies, you don't always go to production with everything. You do some small prototypes, proof of concept. You report build tools. You do hackathons. You do trainings. Use that time to learn something new, so your brain will learn that. Yeah? And what comes next? Maybe language for artificial intelligence, for more cores, for better GPU usage, for FPGAs, for quantum computers. Actually, there is a language, Q#. I even seen it. Or Internet of Things, maybe JavaScript is not the best thing. Or better security, or even language that protects your privacy. Not private method. Sensitive data. Don't ever let it escape, be pushed on the swap, whatever. That can happen. And that is the end of my talk. I don't have time for questions, sorry, because I used too much time. But if you have questions, I will happily answer them in the corridor after. Thank you.